Hello class. So I'm going to walk through this programming assignment, the first programming assignment that you'll be working on. So I briefly showed this code in the class. This is the create data program, which you can use to populate your own table. The way you run this particular program is first compile it, and then basically you execute it by providing the name of the file that you want to create and the number of rows and the number of columns. So this will create a raw binary file. This is optional to kind of work with this, as I'm already providing you with some input test data. This is a slight modification from what I showed in class. So in class, I think I showed the buffer in memory to be a two-dimensional array. Here, I'm just making a one-dimensional array. So it's just populating some data in memory and then writing it to the disk. And you can see it's in write binary. So basically, it's going to write data in binary format. And yeah, this is pretty straightforward. This is something that you can use to debug the code. So for example, this is j is equal to 0 corresponds to the first column. If you want, you can just set one particular number for all the entries of that column. So you can create test cases of your own liking, right? So as I mentioned, you don't have to use this program because I'm already providing you with bunch of input test data. Now, what do you have to do in this assignment? You basically have to work on this code, relational algebra.cpp. Now, this might look like a lot of code, but majority of the code is basically comments to kind of guide you through what's happening. So for example, big chunk of comment about what this function is supposed to do. All right, let me quickly go through this. So the most important part of this code is this relation class. Now, as I mentioned in the last class, we are storing our data in a set where each element of a set is an array of fixed length, and the length is the number of columns. So basically, it's a set of different rows in a table. Now, as you can imagine, set is something that automatically deduplicates. So therefore, you will basically not have copies in this data structure by default. So this is called as data buffer, and I'm also storing this tuple count, which is basically the number of rows that you have. So pause and just think about this data structure, what exactly this is and why are we using this? Um, so this particular class has got two constructors. This is the default constructor, which just simply assigns the number of tuple counts to 0. It's just empty relation. And then this is another constructor, which basically also takes as input an input data file, which we potentially can create using the create data function, create data program, and then basically it populates this data buffer with the data from that file. And then a load from file is another function that you can call to load explicitly from a particular file. So this relation constructor calls load from file function. And then save to file is if you created a relation on the fly and then you want to save that data to the disk. So it saves the data. And then print relation is basically print to the console. And these are a bunch of set and get functions. And as you know in C++, if you want to access the member functions, the member data, then you need to have an explicit, because these are private, so you need to have an explicit set and get functions if you want to use them from outside class implementation. So let's look at the first function, load from file. And this is pretty straightforward. It first reads the size of the file. It's stored in file size, and then it creates a buffer of length file size, and then basically reads the entire data from the disk. Now, once the data is loaded in buffer, it basically populates the data buffer data structure, which is basically set of array. And it basically iterates through the buffer that we just read. As you can see, this is the buffer that we read from disk, and then it populates the data buffer set. And then we also set tuple count as file size by size of int multiplied by array. So file size is the size of the binary file we read, right? And each element is basically an integer. So here you want to divide it by size of integer, and tuple count is the number of rows. So you also need to divide by arity, right? And then save to file. So that's like kind of the exact opposite of load from file. Another function is mm, the print relation. And here I'm showing you basically two ways of iterating the data buffer set data structure. So this is one way of iterating the data structure, and this is the second way of iterating the data structure. So basically there are two things. One is how do you populate the data structure and how do you iterate through the data structure. So you will need both these when you are implementing the tasks that you will have to do in this assignment. So this is basically accessing the elements, and uh, this one load from file is basically writing to the data structure, data buffer. All right. So now this is all that is given. Now the task that you have to implement. So this is basically an implementation of relational algebra. You have to implement the selection function and projection, cross product, and equijoin. So let's quickly look at selection. So selection will take as input an input relation, which has certain arity, and it will return an output relation with the same number of arity. And then basically we are doing selection on certain columns. So this particular function lets you do selection on only one column. So the column index you'll have to provide through this. And then operation, it could be equal, less than, or greater than. These are enums, and they're initialized here. So that's something you will have to use. And then operand is the value you're comparing against. So here I'm providing a detailed example of how to invoke this particular function, right? You can kind of read through this and make a better sense of what's exactly you're supposed to do. Similarly, here you have projection. The input relation has got an input arity. Now the output relation has got a different arity, and therefore this template parameter comprises of both input and output arity. And this is the index of the columns that you want to keep. So here again, you can kind of read through this and make a sense of what projection function is and how you have to implement it. Similarly, you have cross product and equijoin. So now these are test cases that I've provided. So you can write your own test cases here, but these are some predefined test cases. In the first test case, you'll be asked to verify whether your equijoin code is working correctly or not. So here I am creating two relations, case one, input relation one, and case one, input relation two, loading data from this particular data file. Now all the data that I've given, they are just 10 rows. So the first relation has got 5 columns, 5 arity, and the second relation has got 3 columns, right? Now, what are the different input parameters to the equijoin function? The first one is the input relation number one. This is the second input relation, and then one is the number of columns on which you're doing a join. And then this is basically the index of the column of the first relation that you're doing a join on. And this is the index of the column of the second relation. So for example, you are basically doing a join on the fifth column, index 4 of the first relation against the 0th column, the first column, index 0 of the second relation. So this is the data is designed in a way that it is going to produce a output which is same as cross product. And we mentioned, we kind of walked through this in the class, when can we get exactly this kind of output. And then you have case two. This is designed in a way where the output of the equijoin produces 0 tuples. So the function is going to be very similar. You have the first relation, second relation, number of columns on which you're doing a join, and the indices of the join columns of relation one and relation two. And then here you have, which function is this? This is cross product, which only takes it as two input relation, input relation one, input relation two, and then you have the output here. And then this is selection and then projection. So here there is some test cases. Basically, the first one, when you run this, you will see that the first test case fails because the output relation is not populated, right? That's what you have to implement. You have to implement the equijoin function. So let me quickly show how to run this thing. So make sure your data folder is present here. So these are the input files, and you just have to compile it and then run your code. So in the beginning, this is what you will get to see. The way I've set it up is you will get a printout of the relation, input relation for the equijoin. So these are just 10 rows. The arity is 5. And now you can see that the last column is the same value 5. And this is the second relation. The first column is the value 5. Now, when you do equijoin on this, uh, for the last column and the first column, which you can see specified here, column index 4 and column index 0, you will get 10 times 10, 100 rows in the output tuple. So that's something that you will get to see. Currently, you see error in your implementation. The output relation should be size 100, yours is 0 because you have not implemented that. So number of tuples in the relation is 0. This is for the output relation. And other test cases are also very intuitive. And hopefully you will spend some time to go through the code, understand how different components work, loading data from disk, kind of storing it in a appropriate data structure in memory so that you kind of are able to access the data in an efficient manner and also explicitly just do deduplication. And I've put in a lot of effort into designing this assignment. I hope you all put a lot of effort in finishing this as well. And if you have any questions, feel free to reach out to me and the TAs on Piazza. And I'll also open a lot of office hours for this. And I wish you all the best. Thank you.